Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will see the last part of the exponential functions, which is part 5. Let's begin with the first problem. F, g, and h are three functions defined as f of x is e to the power x, g of x is ln x, and h of x is e to the power minus x. And the question is to study the variations of the three functions f, g, and h, then draw their representative curves separately. Try to do it alone. Now for the first function, which is f, the limit at minus infinity is 0 and the limit at plus infinity is plus infinity, and in fact this was memorized by heart. Well, f prime of x is e to the power x. This is positive, so we can tell from here that f is strictly increasing, and this would be the table. The domain, it goes from negative infinity to positive infinity. F prime is positive, so f increases. The limit at negative infinity is 0 and the limit at positive infinity is positive infinity. So this is the table of variations of the exponential function, and this would be its graph. Remember, it has a horizontal asymptote, which is the x-axis. Now let's continue talking about g. Well, the limit at 0 plus of ln x is negative infinity, and the limit of ln x as x tends to plus infinity is plus infinity. This also was memorized by heart. Well, g prime of x is 1 over x, and 1 over x is strictly positive here. Because x is always positive, it's strictly greater than 0, so g is strictly increasing. And this would be the table. The domain is 0 open plus infinity, it's shaded at 0. G prime is positive, so g is increasing. It increases from negative infinity to positive infinity. The limit at 0 plus is negative infinity, and the limit at plus infinity is positive infinity. And this would be its curve. Now we can see from here that the curve of f and the curve of g are somehow symmetric. In fact, they are symmetric with respect to the first bisector, with respect to the line with the equation y equals x. Now for h, the limit at negative infinity is positive infinity, because e to the power minus infinity is e to the power plus infinity, which is plus infinity, and the limit of e to the power negative infinity is 0. While h prime of x, the derivative of this function, remember this is of the form e to the power u, so its derivative is u prime eu. It's negative, so h is strictly decreasing. This would be the table. The domain is from negative infinity to positive infinity. This is a decreasing function. It decreases from positive infinity to 0. The limit at negative infinity is positive infinity. It's here, and the limit at positive infinity is 0, and it's somewhere here. Well, this would be the curve. We can also see that the curve of h and the curve of f are also symmetric. In fact, they are symmetric with respect to the y-axis. Now let's see miscellaneous 2. The curve C at right is the representative curve of a function f, which is defined on minus infinity plus infinity as f of x equals ax plus b into e to the power minus x, where a and b are two real numbers. Now, a is a point whose coordinates are negative 2, 0, and b is a point whose coordinates are 0, 2, as you see here on the graph. The first part states to find the explicit form of f of x, and explicit form means we need to find f of x in terms of x. In other words, we need to find a and b. Try to do it alone. Take your time. Well, if we begin by point B, because it's easier, what do we mean by B belongs to C? This means that f of 0 is 2, and if we go back to f of x and we replace each x by 0, we get b e to the power 0 is 2, and e to the power 0 is 1, so b is 2. So from here we can tell what is b. Now for the second point, which is a negative 2, 0, from here we can also state that f of negative 2 is 0, we go back to f of x, we replace each x by -2, we get minus 2a plus 2e to the power 2 is 0. Well, e to the power 2 is never 0. This means that minus 2a plus 2 is 0, or a is 1. So by now I know that b is 2, a is 1. We replace them here to get the explicit form of f of x. So f of x is ax, and a is 1, so this would be x, plus b, and b is 2 from here, so this would be x plus 2 into e to the power minus x. Now the second part asks to set up the table of variations of f. Try also to do it alone. Try to benefit from the figure. Well, this is the table of variations. The domain of definition is negative infinity, positive infinity. We can see from the graph that the curve increases then decreases. So this would be positive and the other part would be negative, increases, decreases. Well, the limit at minus infinity, when x tends to minus infinity, it's far away down, so it will be minus infinity. And the limit at plus infinity, when x is plus infinity, the curve is strictly above the x-axis, so the limit is 0. Now, when x is -1, we go back to the explicit form. F of -1 is going to be e. So when x is -1, f of x is e. Now let's see the third miscellaneous question. The curve at right is the representative curve of a function f, which is defined as follows, where a, b, and c are three real numbers, and we know that a is a point whose coordinates are -1, 0, b is a point with coordinates 0, 1, and e with coordinates 1, 3, and we also know that t is tangent to c at point e. Now, the first question asks to find f prime of x in terms of a, b, c, and x. This is f of x. Try to find its derivative. Well, this is of the form u times v. So we apply u prime v plus v prime u. And remember here with the exponential function, try always to factorize. If we take e minus x from here and e minus x from there as a common factor, what remains is this expression. We try to rearrange the expression, x squared alone, x alone, and constants alone. So this is f prime of x in terms of a, b, c, and x. Now the second part asks again to find the explicit form of f of x. Remember, the explicit form of f of x means we need to write f of x in terms of x. So in other words, we need to find small a, small b, and small c. Well, try to benefit from the coordinates of a, b, and e, and from this piece of information. Try to do it alone. Let's begin. Well, b01 belongs to c. This means that f of 0 is 1. If we go back to f of x, we replace each x by 0, we get c. E to the power 0 is 1, so c is 1. Try always to begin with points where the abscissa is 0, because these are going to be the easiest points. Well, a -1, 0 also belongs to the curve, so f of -1 is 0. We replace each x here by -1, and we state that the answer is equal to 0. This is what we will have. Well, e is never 0, so we can say that a minus b plus 1 is 0 just by replacing c by 1 from the previous part. Well, pay attention here, the curve c doesn't pass through e, so we cannot say that e belongs to c. But we know that the tangent t passes through the 2 points e and b. And we know also from previous classes that the slope of the tangent is f prime of x, b. So we try first to find the slope of t, which is ye minus yb over xe minus xb, because t passes through the 2 points b and e, and just by replacing we get 2. We replace the coordinates of e and the coordinates of b here, so we get 2. Well, in this case, the slope of the tangent is nothing but f prime of xb at the point B and not at point E. Remember, we choose the point that belongs to the curve, and we know that xb is 0, so f prime of xb means f prime of 0 is going to be equal to 2. And what do we mean by f prime of 0 is 2? If we go back to f prime of x and we replace each x by 0, we get from this expression, we can state that b minus c is going to be equal to 2. But I know from the previous part that c is 1, so b minus 1 is 2 or b is 3. Now we know from the second part that a minus b plus 1 is 0. If we replace b by 3, we get a is 2. So as a conclusion, we can say that a is 2, b is 3, and c is 1. If we replace them, we get 2x squared plus 3x plus 1 e to the power minus x. Remember, we replace them in the original equation. Thank you.